I'm Cole Davis. This is Dave Freeman. We work on the Enyo project. It's a JavaScript framework for developing native-style applications across platforms. I work directly with the framework code. I'm an architect on the project, and he does a little bit of everything.
Yeah, I'm actually part of what we call the developer relations team, and I interface a lot with indie developers and companies that are using Enyo. Is it on? Oh. I interface a lot with independent developers and companies that use Enyo to create applications.
So I'd like to open by saying that there was another guy who's supposed to be here with us today, a colleague by the name of Ben Comby, and he was supposed to be giving this presentation. So he had some lame excuse like, I don't know, his wife went into labor or something.
Yeah, it's like having a baby, or something like that.
But so I'm going to do my best here as I go through his slides and talk about some of this stuff, and hopefully we can generate some interesting conversation. So we're here at an HTML5 conference. Everybody kind of knows the power of JavaScript and HTML and CSS and what it can do for web pages as a whole, and building other tools to help that, like jQuery and whatnot. Like these are very popular. There's plenty of popular toolkits, libraries, and other things that we can use, Bootstrap, that make that kind of a breeze these days overall. But what about creating native quality apps with the web stack as we see it now? High quality user experience that people expect in native apps is something that people think is a myth. We spend a lot of time trying to convince people that you can actually do that. And we know that you can because we've done it. So Enyo powered a bunch of applications that were developed for the HP touchpad. A lot of its core applications were built with Enyo, and then a bunch of, actually a few thousand third-party apps were developed for that as well, using that. And some services like Enyo was ported to Node and used there, but overall we were able to develop a whole bunch of really, really native quality experience rich applications using HTML, CSS, and JavaScript. And they were compared to their counterparts on other platforms. So it was designed as a developer toolkit that would allow them to do just that. And you wouldn't have to reinvent the wheel every time that you wanted to write a new application. And as I stated before, like these applications were developed for the touchpad using these technologies, but they weren't compared to other web pages that would just simply run in a browser. They were compared to their platform counterparts, and they performed as well or better in side-by-side tests. But in order to be able to compete at that level, like for performance reasons, we had to really rethink how you could go about and generate the content of these applications and keep application state. And you're probably thinking, oh God, there's already 10 million other JavaScript frameworks and libraries out there. Like why do we need one more? Our solution is a little bit different than some of the other ones. I've actually had the privilege to work with a lot of really brilliant people and on a bunch of other frameworks and libraries. And this one I really liked because of how easy it is to use. So.
Actually, can I jump in here real quick?
Yeah.
All right, so I met Cole at the Fluent conference in San Francisco last year before he came on board, and they were working on a project, and you can correct me if I'm getting this wrong. We had just actually not even released Enyo 2 to out of beta yet. We were almost there. And Cole and someone else from your company were there and came by and said, hey, I really wish we'd heard about you guys 6 months ago because we just started version 2 of our CRM product in Sprout Core. And they weren't very happy with the way the Sprout Core leadership was going, and just things weren't working out great. Their product was real nice, looked really good, the demo they showed us. But then Kevin Schaff is another one of our framework engineers, went to talk to Cole a little later in the day and said, hey, well, why don't you just try some things with Enyo and see, take it for a test drive and see what you like. And then it was like, oh, this is awesome. You guys did a prototype version 2 in like 6 weeks, you know, and had all of the functionality that they had in their Sprout core that they'd been working on for 6 months. So, and Cole really liked our framework from there on, and now he's part of our team. So.
Yeah, I had took over a project for a company in Virginia that it's a business software company, and we were recreating a project that had been worked on for about 10 years, and they were converting it to mobile. And so we tried several different frameworks, and they had been working on it for about 2 years, and we were able to stop and just play with Enyo, and we recreated pretty much everything we had done over the past 2 years in about 6 weeks. So it's pretty useful, and we saved a lot of money and time doing that too. So there's a lot of other frameworks that deal with a lot of the view-related issues in different ways. We've got templating schemes and a lot of data binding issues, things like that, that they do very, very well. But when building native applications that require very rich interactive controls, you start running into a few other problems than things that you would normally deal with on a web page. And let's see. So an example using, say, handlebars or whatnot, it's great for putting data directly into like a form, but more complex controls pose other problems. Range slider is actually a really good example. Not that it's impossible, but that it's typically not easy to do. And so it may not be the best, templating may not be the best solution in that case. And then normally in web pages, you can almost always rely that somebody has created a jQuery plugin for whatever it is you're trying to do. So you can just grab that, slap that in your page, and keep going. But oftentimes, that's not enough either, because as a whole, in a web page, you get to, for updates to the UI, you can just re-render the entire page, or throw a new HTTP request in there or something like that. But in actual application development, you have to maintain the state of the application beyond being able to reload pages. You have to generate new views. You have to maintain the life cycle of everything that's going into the app. And these are things that jQuery does not handle, and things that typical web developers don't even think about a whole lot. So that's where kind of UI plugins tend to run out in terms of their usefulness there. So instead of having to, I don't know if you've ever tried to do that, is create a life cycle for a web page. Doing it once is enough to show you that that's something you don't want to have to do over and over again. So enter our general approach to this is using components. And the overarching concept of components is the ability to encapsulate behaviors. You get to take a chunk of functionality in an actual object, and you wrap all of it, the life cycle management, its ability to render itself into the DOM, its awareness of other events and data binding, all that logic, its own structural API, goes into it as fully encapsulated object and can be reused throughout the app. It takes the markup, any event handling from the DOM, any of its logical state and lifecycle management with constructors and destructors and pre-post renders and things like that. And you wrap that nice little box around it all, and then you just are able to expose a little bit of that API and mask everything that's underneath that, or the implementation detail. And if that sounds familiar, that's because if you've ever taken computer science classes or any object-oriented programming languages or anything like that, you've seen this before. This level of abstraction should be pretty familiar. But we can look at a simple example, say, of this typical slider here and see what that would actually look like. And let's assume, for the sake of this example, that all we needed were these 4 divs to actually create the structure, and we have some CSS that makes it look pretty. And then, well, let me just go ahead and point out here that that structure here in the markup in Enyo looks like this. you can define the static DOM structure in these object literals in a components block, which is a pretty elegant way of representing that in a data structure like that. You can override, overload, add to, or use the lifecycle management methods to deal with the creation and execution and destruction of that object as it's in the application. And then we've got all our event handlers and then any kind of API logic and how it interacts or can be interacted with other objects. Now that we have that object defined as a class, we can start slapping it in wherever we want, all over the application. And I think you can probably run with that thought, and you start to realize, well, you can create a bunch of really cool, rich, interactive widgets that can go into making an application function. But if we stopped right there with everything we've described so far, you wind up realizing that, oh, this is nothing more than a framework that can create, a widget library, yeah. Yeah. But the cool thing is that components don't just deal with the static DOM elements like divs. You can then start creating more complex views based off of other components that you've already created. So say we had a very basic component that took, I don't know, a text and it just renders it into a div, and then you've got another very similar one that then has an integer value. Combined, we can create a new class called valueLabel, which then we have set content, set value as our API, and we can change the label and the data value at any point in time. We can run with that a little bit further, and we see that, well, if we add a slider to that and make sure that that slider's current value is the same as in the integer label, we've got a slightly more complex view there. And we can even keep going, add a group box and multiple label sliders, and we have an attribute view. And you just keep generating more and more complex views as you work up the tree. And then let's say we had another one, which was for a contact. Combine it with the attribute view, and we've got a contact detail view. And we could easily create those by passing in some data, say a model representing this, that contact and all the information associated with it. And I think that the picture should start to become more clear that you can treat this level of abstraction. You start dealing less with the actual DOM-related HTML markup and more with the higher level object APIs. As you break down those pieces, it's not until you get to the simplest of them that you start looking at the actual structure. And although I'd like to point out you can deal with that all the way up the tree, and there's nothing keeping you from being able to do that.
Yeah, you can definitely, take full control of everything that Enyo does, but it's typically the goal of an Enyo developer, I think, to not ever really touch the HTML anymore, right? Because you're just declaring all of these components and their ownership hierarchy, which ones contain other components, et cetera, and let them render themselves into the DOM correctly. Now, if you have specialized needs, say, well, I want this component to be owned by this component, but I actually want it to render itself in this other unrelated container, I can do that, right? But that's a specialized need. So like I said, most Enyo developers, the goal is to not ever really have to touch the actual HTML unless you really need, absolutely have to. You just kind of customize with CSS and use the component hierarchy to lay everything out correctly.
So I kind of want to briefly go over an example of a slightly more complex component that is built into Enyo, and that's our list object. If in applications, you typically, well, for example, say an email application or a contact list where you have very lengthy data sets to represent, or in email or Twitter feed or something like that, where it's like an infinite scrolling list. Those can be really hard to deal with out of the box in web apps or using the web stack as a whole. And there's been lots of different solutions to that. We have one way of doing that using a flyweight pattern. And as a component, this becomes pretty trivial. So I don't know if you can actually read that. So basically, you get to define it just as you would, as I described any other component, simple like the slider. And it uses a template, its own component, to describe the structure of the actual row. And it only maintains a single reference to that template in the memory at any given time, and it just stamps out a subset of the whole data set into 2 separated pages. So if you tried to render 10,000 DOM elements, I don't know if you ever tried to do that, 10,000 or even more, it can really be resource intensive on especially the smaller mobile devices. Some of those browsers will crash. It's a very slow thing to do, even in desktops with powerful processors. And so typically you want to find ways to avoid that. So the flyweight actually will render, like I said, a subset of the whole, and it allows you to scroll seamlessly as it will actually adjust to your position in the data set and move the pages around as you need them to. So you get this smooth scrolling experience that's very lightweight on resources and gives you a native-like experience with infinite lists. And as I was saying before, it's just another type of component, so you can define it the same way, drop it into other components as needed, and then you can use other complex components as the actual row template as well, depending on what you're trying to show. We could have done that with that more complex content or contact detail view or whatnot. So where do components run out in their usefulness? Well, this is kind of where I come in here, because when I started working on this, my task was to try and introduce a new way of handling data with our views. Initially, Enyo did not have a standard way of modeling data or dealing with that in the view. And this, in larger data-centric applications, this can cause a lot of complex problems, especially when you need to share that data throughout an application. And this is actually a problem that's not just something that's dealt with by Enyo, by the way. This is something that you've probably all dealt with on a daily basis when doing any kind of web development. If you pull in data somewhere, you need to share it. You have to think of ways to actually get that data to other places and synchronize it throughout the web page or the app, or maintain state through like local storage or other things. Like, this is a very common issue that has to be dealt with. And you wind up writing a lot of boilerplate code over and over again, slightly varied ways because you're in a hurry. And yeah, it's very tedious to do over and over again. Enter MVC. In presentations, I usually wouldn't like to read a quote. I love this. This is Martin Fowler in his description. He says, different people reading about MVC in different places take different ideas from it and describe these as MVC. If this doesn't cause enough confusion, you then get the effect of misunderstandings of MVC that develop through a system of Chinese whispers. So every time somebody says MVC, I think that its meaning changes just a little bit. And being aware of that and coming in here saying MVC, I'm not going to pretend to be the authority on MVC. But I understand some of its overarching concepts enough to say that I like the separation of concerns of MVC. I like the fact that we have a view that deals with presentation related issues. I like having a model layer that is dealing with data exclusively and state of the application, and that you've got a control layer, which is the liaison between those, because it's actually taking user interaction with the application, translating that to how it should modify the data, and then the data gets to then change state, and the view will respond to the state of the models. And is anybody in here not familiar with MVC at all? Okay, good. So there's lots of things that are supposed to be MVC, and I have worked on a lot of frameworks that claim to be MVC, and not one of them was the same. So that being said, there's lots of other derivatives of it. That last one I made up, but it would be pretty cool. So So yeah, so a lot of the derivatives were intended to take some of the better concepts or parts of MVC and apply them to the way that the technology stack has changed as a whole. Like, this is true for applications of any language on any platform. It's not just on the web stack, but things have changed since the 70s in Smalltalk, and so we have to kind of adapt to those. So my approach wasn't intended to be having a pure MVC or be able to claim that I had pure MVC in Enyo. And I also wanted to be able to preserve the simplicity and beauty and elegance that was using components for the view, which actually, at times, is a harsh contradiction to MVC. But it's flexible. You can apply it to your application needs. You can have tight coupling of controllers that are aware of the view that they're modeling for. You can have controllers that are owned by views. The views interact and delegate tasks to the controllers as needed. You can have stand-up controllers, which are application scoped, that deal exclusively with data and know nothing about anything else in the app. So there's lots of different types of controllers, and you can use them as necessary. Some of the other things that I added to Enyo now are an observer pattern. We've got computed properties and the mixin pattern and data binding and a few other pretty cool things that make it, in my opinion, a lot more versatile than it was, and it was already pretty versatile, so it's just getting better.
I can attest because I've done a lot of standard Enyo code since long before Enyo was actually out, and have recently been trying some MVC changes on some internal projects, and it has really simplified a lot of things, especially around those lists, right? He's got a couple of nice the collection repeater and the collection list he'll talk about here in a minute, and it's as simple as making a model of these data objects, shooting it to the list, and it's done. I don't have to deal with even templating my rows anymore if I've got my model item set up correctly. So it's great for me to watch this progressing, because it's not ready yet, right? It's still being worked on. But the code that I've been writing just as my own test ground is very exciting. So that's good.
Just a note on that, on the release stuff, we're actually going to have a public preview of all the work that I've been doing. It should be released next week, right after our Enyo's 2.2 release. That's been a little late coming here. But as soon as 2.2 goes out, the public preview will be available and people can play with it. Technically, you can go play with it now, but it's in a pretty volatile state. So just a brief discussion on some of these elements, just describing what they are. Data binding as a whole, I usually think of, if you've never used data binding, I think of it more of like a tether. You've got two objects, and each object has a property, and you kind of like have a rope tied between those two things. And when it changes on one end, it's going to automatically propagate a change of that thing to the other end. And so you can have one-way bindings, which means that it only cares about changes on one end to propagate it to the other end. You have two-way bindings where if it changes on either end, the other end will be notified of the change and updated. And you can even use transforms to intercept the propagation of the change to either change the value that's going directionally, or you can actually stop propagation entirely. The controllers are like the jack of all trades. They're technically a component of types. They intercept and deal with the event system. But primarily their duties are to proxy information to anyone who is interested in it by binding to it or listening to its events. And then you can change the underlying data and automatically have that change propagated to any of the views or other controllers that were interested in it. And it allows you to maintain state throughout the application, which was a little bit harder to do before, and it's very hard to do on your own without tools. One other thing that I was working on was having some built-in support in Enyo for Backbone, and I will give an example of that here shortly as to how I did that and what that means. But I don't know if you've ever used Backbone, but it's a pretty handy tool. Not that you can't use other tools with this stuff, it's just this was the first one that I was working on, and it's turned out pretty well. So we can look at a few examples. This will actually give a better introduction to some of the elements in when you're building Enyo applications as a whole, and you'll get to see some of these newer pieces here. So there's a concept of an application, and an application is really just an encapsulated component that it owns a base view, which is typically the top of a tree of lots of views that build a complex structure, and you have control over when it renders and where it renders into. You can, by default, it's going to render into the whole entire body of the DOM, but you can specify an actual node and it'll render it into that. You can have multiple application instances running at any given time if necessary. So here we built out a very simple application object. We say that there's a default view, tell it to render whenever it's created. And we go and define this view. We add a simple class, and we define some bindings. So just like the components, we call this the components block, where it's just an array of declarative style object literals with information about the kind of component that it's going to generate. Bindings are somewhat similar, and they have a pretty simple to understand API. I get to describe paths, or I could assign actual references to objects if I had them, but here it's pretty simple. These are relative paths. $sign is also an Enyo specific thing. Every component that generates named children has a special $sign object which maintains references to those children. So it makes it pretty convenient when trying to get references to children that are underneath you. So here we bind the value of this text field to the content of this empty view down here. And what that actually does, very simply, is as I'm typing here, you see real-time changes in the content of that lower level div that was generated. So this is probably in its simplest form how you can use bindings in an application or between two divs. I'm not sure that that's entirely useful, but at least shows you how you could do that. So in this one, what do we do here? I have the same one twice. Okay, so for each one of these, I'm going to get a little bit, it's going to be slightly more useful, I think, as we move up here. So we've got a transform here, and we put a placeholder on our Enyo input component here. So why did I use a transform? Well, bindings as a whole don't understand the data type that's supposed to be on either end. And if you're telling it to change from one end to the other, if it's an undefined value, it's going to put an undefined there. If you try and set undefined as the content of an HTML div, it's going to say undefined. We don't want that. If you put undefined as the value on an input field, it's going to say undefined. And we don't want that here either. So I catch this using a transform. There's lots of ways to use them, but this is one way. I actually just use a string to name the property on the parent object here. And it gets past three values: the actual value that's going through, the direction, whether it's coming from the source or going to the target, and then a reference to the actual binding. And I check to see, is it a truthy or falsy value? And if it's true, then I just pass the value all the way through. Otherwise, I grab the placeholder and put that in there. So that way, if I do this, so now we're seeing what we had before, and I back out, and it's going to go back to the placeholder as opposed to saying undefined. Here, I'm going to start using controllers a little bit to kind of describe what you can do with those. Controllers allow us to proxy data, and one way to instantiate them, there's lots of ways to instantiate them, but you have this controllers block on application. These are application scoped controllers. This name actually becomes the path. I can reference this anywhere in the application or say in the console. If you're debugging something, you can use that to find the controller reference. And so the application actually will create that object when it's created itself. And here in the default view, I now say I'm going to bind from the full path to that controller and its data property. I'm going to bind that to the input value like we were doing before. I set the one-way flag to false, meaning that we now have a two-way binding. Changes on either end will modify the value, and everything else should remain the same. and then I gave it an initial value down here. That is initial value. Now, without having access to the console, and I don't want to change things up too much right here, but it's functioning the same way, although the binding is actually pretty different. It's not binding the two divs together, it's binding via a controller that's proxying the value. That means that the value being set on that global controller here could be referenced from any other view or any other controller in the entire application and have the same value being changed in real time. Springboarding from that, we still have our controller. I changed it out from the default controller, and I am using a built-in type called object controller, which now knows how to proxy something that is like a data model. It can be a normal data hash, it could be or like a native object literal, or it could be an Enyo object with any kind of structure. Here I defined an Enyo object, and I called it data object, and I just gave it some, this is just to define what the fields would be on it. Gave them some initial values. Go back here, I recreate a slightly new structure to our view. I have 4 fields, or 4 divs now, and they all have names. And in the bindings block, I go and I bind from those fields on the object controller, and not the object or the model directly, but the actual object controller, and bind this to the content of these divs down here. After the application is actually already rendered into the DOM, I then go set the data property on the controller to a new data object, and I gave it some initial values here, and you can see that those have been propagated into the view. If I were to go call x.controller.set first to some other thing, it would then take on that in the view. Getting a little bit more complex here, we see that I'm going to use a computed property to take the first and last name and create a new field called full name. So this is not a part of the model anymore. This is on the controller, but I'm also going to play around with some other features here. Let's say I had 2 data objects, and I wanted to be able to switch between them just with the click of a button. Well, I have an index. I have a data set now, which is an array. It could be a larger data set if I wanted to. In this example, I just set it to 2. But so computer properties have this notion of dependencies. So anytime that these properties are notified as having been changed, anybody who's bound to this property will be notified of that change as well, and they'll receive the new value. Data itself is actually a computed value, and it's going to use the set index on the controller to return the correct data object from the data set. We still have our definition of the data object, and in the view, I set the view's own controller reference to the global controller I created. I set the bindings. You'll see that I changed the structure. It's now no longer 4 elements, it's 3 here. And I've got full name, which was that computed property, controller, full name, and then I added a new one, which is a button. And the on tap is going to send a next event to the controller, which you'll see I have a name here called next. It's going to interpret that and change the index, which then will fire the change event for the data. And then we'll see that when data changes, the view changes. Growing up from this, we'll see that if you have a larger data set, it would be really, really tedious to try and deal with the index of the data set and all that all on your own. Like, it's just dumb to have to do that. I did it for example purposes only. I think in the next example, I'll show how to use an array controller to deal with array-like data sets. But here I was just going to show an introduction to using actually it's the exact same example as before, except for now I'm using a backbone model instead of an Enyo object. You'll see I just create a simple model with defaults, just like I did with the Enyo object. I change the controller type from Enyo.objectController to model controller, and everything else remains exactly the same. I set the data set to new models instead of the new data object, and it functions identically. So moving forward with that one, we've got a new backbone model. I introduce a backbone collection so I can have lots of models. I still have my model controller that's overloaded with the full name computer property. In the application, I set the kind of control from model controller now to collection controller, so it can deal with the actual collection. And I pass it a reference to the actual Backbone collection that I created here. Actually, this is just a class, but it knows how to instantiate that. So in the view, I tell it that its default child controller for any of its, actually, let me also state that this is a collection repeater. It knows how to take the data set and render that into the DOM as a whole. The repeater is a pretty dumb class overall. It can be extended to do lots of different things, but it's designed to take large data sets and repeat whatever the template is into the DOM. It has no awareness of what your layout is or what you want it to look like. That's completely up to you. So that's its basic function. But it's normalized to be performant in how that it updates the view. And so in our components block, we have the same bindings as we did before. This is going to be the thing that's wrapped up and used as the row template, or in this case, it's a row template. It's really just a child template. We set the default controller to our overloaded model controller, which will be supplied to each active view, which or row in this case. Oh, good point. So there is a mix-in available in the new stuff called Autobindings, and what Autobindings do is they give you the opportunity to use a different syntax for declaring how the bindings are. Instead of using a bindings block on the parent object and relaying the bindings to any of its children, sometimes that actually is really easy, and sometimes it's not, especially if you have some nested kinds in the component tree. But using Autobindings, there's a new syntax. On the children themselves, you can declare the fields that you want them bound to. You can declare transforms, one-way state, and a bunch of other features as well. So that's the syntax that I'm using here. Repeaters automatically use them. The collection list will automatically use them as well. So that's why you're seeing that. But bind from is part of the Autobindings feature. Remember that I have a collection controller now, and it has an exposed API that is very similar to the actual Backbone collection. Functions similarly. I just passed in an array of these data hashes, and it creates models for them. I call appRender, and I see that it generated those two elements into the DOM. Taking that a little bit further, I think the only thing I changed here was I'm using a collection list as opposed to the collection repeater. And I added a new model, so you can kind of see that, but the syntax for that is the same. And Ben deserves that. Well, built-in integration. I mean, you could actually, like, something that I don't show in some of these examples is the fact that underneath the collection controller that's used to deal with the Backbone stuff, there's something called an array controller. That they have identical APIs, which means that you could then take an array controller and use it with any type of data. It doesn't have to be a Backbone model. It doesn't have to use Backbone collections. And so the collection repeater, collection list would actually be able to function the same way with the new data type. All right, so taking everything that I've talked about so far and generating a slightly more complex scenario, I have a much larger data set, and I don't think I can get all this on the screen well, but so we've got lots of fake, poorly named people here in this contact list, and they have an age and an email address. And so using Backbone, I create a generic Backbone collection. I generate these 100 fake people or contacts in here. I overload a model controller to do two things. It will accept two named events coming from these two buttons, deselect and destroy, where they interact with the model directly. And I'll show you how that changes the state of the view without actually modifying the view directly. We have a collection controller that has some overloaded functionality. And of course, like, I'll show you these links to these. You can go look at the comments and play with them if you want. That's kind of why I'm glossing over them now. But this is how the controller actually interacts with its own data set. And the add model is coming from an event from this button for the add random, because although the model controller has the opportunity to intercept that event, it has no awareness of the actual collection controller, so it can't do anything with it. So it gets passed up until it hits the collection controller, which would then add a new random person. There's some additional stuff in here showing how you could intercept the different events, like an added field. And I automatically select when I select the newly added or generated contact, and then an overloaded view below this, I'll show that it catches the selection event and then scrolls to that if it's the last element in the list. The application is a little bit more complex. I actually have two controllers now. I've got my collection controller, and I have a model controller that is now going to proxy the selected model from the list. Collection controllers have built-in support for selection, and so when I click on an element in the list, it actually will select a model. The binding from, let's see, right here, where I have selection from the collection controller, I'm binding that to the data property of this model controller. And then my editor view is bound to the data in this model controller, so that's why it's representing the selected element in the list. In the root view, I'm just using some built-ins and layout for Enyo that you can explore that just are laying it out in a column layout. I'm setting a controller to the collection controller. I define my components where I have only two nested kinds. I've got my overloaded collection list, which is doing this, and I've got my editor, which are these fields here. The collection list, here's where it actually deals with the selection changed event, and it's calling its super method, and then if the newly added or newly selected element is the last one on the list, it's actually going to scroll to it. We'll see that here in a second. So we've got our row definition. It's very simple with just those fields. Here I have an extended version of a binding that I can reuse without having to redeclare each one of those properties over and over and over again for the fields and the bindings. The editor itself is fairly simple, but I was showing that you can set the bindings in different ways. It has these two elements. This is a bound property to the length of the collection controller. You'll see its content is actually declared here in its subcomponent. These are tags span. Beneath that, we have those four fields, which have I'm using Autobindings support here for these. And I set my default binding type to that overloaded binding type, which will allow us to keep this minimal here. And we've got our buttons declared. Each has their own distinct and unique handler mapped to the on-tap event. And then I generate the app, showing this in a larger set here. So I can scroll the entire list here, and I can select any element. You'll see that the data is automatically propagating based on the selection. We've got real-time interaction from the editor going back. This is handled automatically. There was no additional code required for me to do this other than setting the initial bindings. I can interact with the state of the view here indirectly by changing the state of the model, setting it to selected false, automatically re-rendered that row as being deselected. I can destroy models, which means you'll see it disappear from the list. Also note that the length of the list has changed here, and it cleared the editor. And as I start to add random, the resolution on the screen is wrong, so couldn't get all the way down there, but it's automatically scrolling to the bottom of the list and automatically selecting the newly generated entries, and you'll see that value is increasing as I'm adding the elements. So highly recommend going and playing with some of this stuff. And yeah. So it looks like we've gone over, and I think that's the end of that. So I apologize for not being a little bit more polished on that. I wish Ben had been here. He's a much better presenter than I am. But I can answer any of your questions after at any point in time. Feel free to contact us directly with our email address or check out some of these examples. Or check us out on the web. Well, we can answer questions afterwards, but thanks so much for being here. Appreciate it, and have